Example 2 in Stat 101, Examples Class 4, Conditional Probability. We'll be using the formula that you'll find on the Stat 101 formula page. The probability of A given that B has already happened. Probability of A knowing that B has already occurred. So our formula is the probability of A intersection B divided by the probability of B itself. The conditional probability formula. Our challenge, 20 cards are numbered from 1 to 20. One of them is chosen at random. Given that it is less than 14, what is the probability? It is a multiple of 5. The word given is the clue that we're looking at a conditional probability question. The words given or the words if leads us that it is a conditional question, a conditional probability problem. Starting by defining our sample space for this experiment, 20 cards numbered from 1 to 20, our sample space shown in curly brackets will be the numbers 1, 2, 3, 4, 5, etc. up to 19 and 20, our complete sample space. Letting event A be less than 14, choosing a number less than 14, showing A in curly brackets. A would be 1, 2, 3, etc. up to 12, 13, close our curly brackets. Event A. If we define our event B as a multiple of 5, which of those cards make up our multiples of 5? B, shown in curly brackets, would be 5, 10, 15, and 20. And looking at A intersection B, what's happened in A and also happened in B? A intersection B would be the events common to both. And we're looking at event 5 and 10. Two cards giving us A intersection B. Representing this information on a Venn diagram, a sample space shown as the rectangle, we will have event A as one circle and event B as a second circle overlapping the first. Putting the values in the correct positions, A intersection B, the overlap of the two circles, we have 5 and 10 inside the overlap, leaving us 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, and 13 in event A only, and 15 and 20 in event B only. Remembering, our complete sample space is made up of numbers 1 to 20, so there will be some numbers that don't fall inside A or B. The 14, 16, 17, 18, and 19. The Venn diagram is useful for the conditional case, given that it is less than 14. So we're looking at event A. Event A has already happened. What is the probability then that it is a multiple of 5? What is the probability it's a multiple of 5 given that it's less than 14? Those two numbers out of a reduced sample space this time, out of a possible 13 values. So our probability would be 2 out of a possible 13. A reduced sample space, we're not looking at all the 20 numbers, 20 cards, we're looking at only the ones in circle A. Using the conditional formula, conditional probability formula, to verify our answer. probability of A given B. Remember, this time it's probability of B given A. Always remembering, is it A given B or B given A? Probability of B given A this time. Just always checking before we proceed in the question. So in this case, actually probability of B given that A has already happened. Very important we get those the right way round. So probability of B given that A has already happened will be the probability of A intersection B. Same as probability B intersection A, doesn't matter which way around we write those, divided by the probability of A in our case. So probability of A intersection B, we have two values in A intersection B out of a possible 20. So the probability of A intersection B is 2 divided by 20. Looking at the bottom line, probability of A, we have 13 values in A out of our possible 20. So our probability of A itself is 13 divided by 20, which simplifies to 2 divided by 13, 2/13, which agrees with the answer that we find from the Venn diagram. Both methods perfectly valid for finding conditional probabilities. And that's the end of example 2.